Hi, let's get on with looking at the periodic table, the separation between metals and non-metals, further look at periods in the periodic table and some trends. And so let's get to it. Now, metals and non-metals, I've probably mentioned this already, but on the periodic table there is a diagonal step line that starts with boron, and although I'll hold this up, you probably won't be able to see it because I'm just a tiny little thing in the corner of the screen. But have a look at your own periodic table and you can see a thick black line, and it's a staircase. And that staircase is what we use to separate the metals from the non-metals. Metals are found on the left and non-metals are found on the right, and it's not a hard thing to remember which is which. You just think of something that is a metal like iron, gold, silver. Find that on the periodic table and then you know you're on the side where the metals are. Now, the change from metallic character to non-metallic character, so going from metal to non-metal, is gradual though, and some elements have characteristics of both metals and non-metals, because basically we ask you what is a metal and what is a non-metal, and when we do bonding models we'll explore that a little bit more, but this is just how we use the periodic table to classify them. Elements that have combinations of metallic and non-metallic properties are called metalloids or semi-metals, just to confuse you some more. Now, here's a periodic table, not exactly the same looking as yours, but it's exactly the same periodic table, of course. There's our staircase, and here's a blow up of the staircase, and so you've got your non-metals and your metals, and then you've got these guys which are metalloids. Now, we don't really go into metalloids in any great detail. You might in year 12 chemistry. Now, the trends. The reason chemists put elements in the periodic table is that it's a useful way to look at trends and various other things. So if we look at going across the period, so across a horizontal line, the metallic character decreases, the atomic size decreases, the reactivity decreases, and the electronegativity, which is the ability to attract electrons, increases. And this is the explanation. Basically, it's because there's more protons in the nucleus, and therefore it's pulling things in. So you can pause and have a read of that just to reaffirm that. And when we go down a group, remember a group is a vertical column, the metallic character increases, the atomic size increases, they get bigger, the reactivity increases, and the electronegativity decreases. Okay, and basically that's because the atoms are getting bigger and the electrons are getting further away as there's more and more electrons, because as you go down the group you're increasing the number of protons quite dramatically. Now, if we look at the periodic table, hopefully my mug isn't in the way here, but as we go down a group, and let's just use group 1 as an example, we add an entirely new energy level to the electron cloud, making the atoms larger with each step. Now, what does that look like? And so as we go down this group here, there's our proton, for example lithium, sodium. This is what the atoms look like. You can see that they're getting bigger because the electron shells get bigger and bigger. Now, in terms of electron configuration, however, they go from, which is 1 electron, next period must have 2 electron shells, so 2, 1. Third period must be 2, 8, 1. So the electrons start filling out, and we're just about to do some more work in the next video on electron shells. So this is a way of writing the electron configuration. So it gets more complicated as you go down because they get more and more electrons. And remembering, as we go across the period, the size actually decreases, even though the number of protons increases. So the nucleus is getting heavier and heavier, but it's also getting more positive. And that more positive nucleus draws the electrons in closer and closer. And so some people might think, well, as you go across the periodic table, the atoms should get bigger, they actually get smaller in terms of the space an atom occupies. And remember, the definition of the space an atom occupies is defined by the outermost electrons. And so those outermost electrons are being drawn in towards a more positive nucleus. And this is just showing it. Here we have element 11 drawing its electrons in. We add another electron, we add another proton. The force between these guys is increased and they get drawn in more. Okay, add another electron, they get drawn in again. And one last go. There we go. So each step we add a proton to the nucleus and an electron to the existing energy levels. We're not making any more shells because we're talking about being in the same period, and that attraction draws the cloud in, and so atoms are smaller. Now if we look at the periodic table as a whole, this is the representation of the size of the atoms. As you go down a group, the atoms get bigger. These guys fit in just here, so we can see that it's a continuum from there right across to there, from there to there to there. Okay, pretty neat. And in the next video we're actually going to look at those electron shells and how we draw them and how we number them. See ya!